Okay, now we'll start with time complexity. So time complexity is a computational complexity that describes, as we discussed, it takes, like, it is expressed as an amount of time taken to execute that particular code. So it is commonly estimated by counting the number of elementary operations as well, because if you execute the code, you can just start time and end time you can take off the code, and difference between is the time complexity. But even you can do it in other way, like while executing the code, how many steps it will take to execute. So based on that also we can check it. Assume that each elementary operation takes a fixed amount of time to perform, and then thus the amount of time taken or total number of elementary operations performed by the algorithm is again T of phi equal to C plus Tp of I. Again this I is again instance, like C is a compile time independent of instance characteristics, and total run or execution time is Tp. So that is based on the instance. So let's discuss one method. This method we can call it as a step count method. So it's like we are just counting the number of steps to be steps taken to execute this code. So I am just taking the example which we have used for our space complexity, so which is used to sum the list. So we are just dividing, we will just check the execution of each and every line, but we will divide it with respect to how that line is executed, or how many times that line is executed. So this is a definition of a function which is a callback to the function. The execution of this line may not happen. So this is steps or execution. This is frequency, like how many times this will execute, and total number of steps are S or E multiplied by our frequency. Okay, so we will be calculating these values. So now here frequency also we will just take 0. Now this is a variable sum, and once you enter the function, this will be executed. Okay, and this will be also executed one time only, because only one variable is there, so we will be executing that one time. So what about total steps for this particular line of code? It will be just taking 1, the previous one is 0. Now here we are calling it as a for loop. So what it will do, like you can just check here, in other programming language this is a Python code. In C you have been given I equal to 0, then I is less than or equal to something n, or then I plus plus we will be having. So what this does, or any other programming language there will be some different syntax. So for I in list 1, so how many times this particular line will be executed? So execution will be once every time, but the frequency will be for this for loop is, if list size is, let's say, n, the size of list is n, then this for loop will execute actually n plus 1 times, because it will be checking. See, list is having, let's say, size 4. Okay, I'll be just taking 4 elements of that list, and now for loop is applied. So it will check A is there, so first B is there, C is there, E is there. So these 5 have been checked, and it has taken those elements. But this is the end of that list. For loop doesn't know, so it will again come back after that and check is any still element is pending. That is why this n plus 1th will be checking the instance, that checking is there any element is still present in that list or not. So that is why it is n plus 1 times it will be executed. This will be again executed once, but what about sum term? Because you are going inside the loop for only n times, so that is why it is n. Okay, so now what is the frequency? Total steps for this line, it is n plus 1, and total steps for this line is n. So always remember, the for loop line will be executed n plus 1 time, and that n plus 1th will be taking it, that steps is, or this step is false, or whatever condition is there is false. That's why we are just coming out of the for loop, but it will go inside the for loop for n times. Okay, and then return will execute it for one time. So this is again 1, and now you have to sum the total number of steps, so that we can just get it how many number of steps are needed to execute this. Okay, let me just erase some part here so that I can write it. Yeah. So now you can just see, if I sum 1 plus n plus 1 is n plus 2 plus n, 2 plus n, 2n plus 2, and then it is plus 1 is 3. So I'll be getting total number of steps are 2n plus 3. So this is a method of step count. Yeah, in next video I'll take one more example so that it will help us to understand